Hello everybody, welcome to a new video about using open source software to generate G-code for your CNC. In this video I'm going to talk about the new Blender add-on called FabEX CNC, formerly known as BlenderCam, to make pockets just as we are used to in FreeCAD. Let's try to make them in Blender. There are some differences, some of them are good things, some of them are bad things. So let's get started and I will explain along the way all you need to know about how to make pockets, the tricks that I sometimes use. Before moving on, I want to thank everybody that supports me through my YouTube channel or through my Patreon page. Any help means a lot to me, so let's get started and hopefully you will learn something new today. As you can see, I'm using an imported shape. I'm not going to create it in Blender. It is an example from FreeCAD. So let's go to FreeCAD and export it as an STL. Then I will delete everything from this file and start over. Using this shape, I will import it and then I will show you how to make the pockets in FabEX CNC. I'm in FreeCAD. I have the part design example open. I will select the body, go to File, Export, select the folder, click on Save, and now let's move back to Blender. I will delete everything just as I've said. Now let's go to File, Import STL, and select the file. I will change the scale from 1.0 to 0.001, otherwise the imported object is too big and I have to resize it. Selecting the proper scale is a good thing. Click on Import STL and now I have the object correctly placed. Well, it's not correctly placed, it is correctly imported. I still need to move it to the positive X, Y and Z, and for that I'm going to Object, Transform, Align Objects, change the align mode from center to negative sides, change the relative to scene origin, and first align the X, select the object, go to Object, Transform, Align Objects, do the same for the Y, then click away, click again on the object, Transform, Align Objects, and now let's align it on the Z axis. As you can see, it is correctly placed, but the little white dot here is the origin, which isn't correctly placed for now. For that I will right click on the cursor, which by default is in the center of the 3D world, in the center of the scene. So now select the object, right click on the 3D cursor, go to set origin and select origin to 3D cursor. As you can see now the origin is on the lower left corner, which is exactly what I use on my CNC. If you have a different setup, you can modify the position of this object and then change the position of its origin. Now if I go to item, I have a little difference here, but it's not a problem. I'm going to apply all transforms and now the value is 0. So how do you create pockets? If you are used to FreeCAD, you might want to select surfaces, but this isn't the case in Blender. It works a little bit different. Let me show you how to generate the curves for the pockets that I want, because that's what Blender uses, what FabEX uses to generate the toolpath for the pockets. In order to do that, I will have the object selected and from the left menu I have Get Pocket Surfaces. After the first click there's nothing happening because there is here a Z limit which I have to change. The Z limit is the top surface that it will take into account. Since it is Z0, nothing happens. Selecting the object, I can see it has a height of 100 millimeters. Now click again on the Get Pocket Surfaces and let's change the Z limit to 100. Click somewhere else. And you can see I have several objects here under multi-level pocket 001. I forgot to delete the first one. So let's see which are the surfaces. I will hide the object first. And now you can see the 3 curves that it generated automatically based on the shape of the object. I have the surfaces for these 3 pockets, the surface for this, and for the circle at the bottom. Now let's start generating the toolpath. The first thing that I want is these 3 notches, I don't know how to call them. I want to make the toolpath for them, so let's have them selected and click on the plus button next to operations. After creating the operation, you can see it here in the tree. I will go to the CNC menu from the side menu. If you don't have this menu open, press on the N key on the keyboard and it will toggle the visibility of this panel. The default strategy that appears here in FabEX CNC is the profile, the cutout, which I don't want for today's video. So I will change the strategy from profile to pocket. And now let's make some settings here in order to get the correct results. If I use the default settings and click on the calculate path button, you can see I have an error. So let's take them one by one, set everything as it should be, and then you will be able to have the correct toolpath for these pockets. The type of the pockets is perimeter or parallel. I will use perimeter, which uses some sort of offset from the outline of the pocket. The start position, obviously inside or outside. I will select outside. I want to mill everything from the outer portion of the pocket. I don't want to leave any skin. If I want to make a final pass to get smoother results on the walls, I could use a little skin and then make a final operation to remove that material. And the last setting here that is important is the toolpath distance. The toolpath distance is the step over, which means the amount of overlapping when the tool bit removes material. Unlike most of the other programs in FabEX CNC, you don't have a percentage of the tool bit diameter, but an exact measurement in millimeters. So if I'm going to use a 6 millimeters tool bit, I want a 50% step over. I'm going to set a toolpath distance of 3 millimeters. Scrolling down to the operation area, here I have a safe height and an operation start depth. Since my object is 100 millimeters high, I will use a safe height of 120 millimeters and a start depth of 100 millimeters. The max depth, which is the lowest depth the cutter head will go, I will leave it from the object so it will take into account that height. I'm also going to use layers. Since I'm using a 6 mm end mill, I'm going to use half height layers, 3 mm layers. The next section is the cutter section, where I have by default selected a 4 mm end cylinder because that's what I used for the last operation that I have created. I'm going to select the 6 mm end cylinder from the list and double check everything is correctly set here. So it's a 6 mm diameter, the type is end mill, it has 2 flutes, this isn't so important. Here I have an info, which is the engagement 50%. As I told you, this is the step over calculated based on the toolpath distance between each pass. So now let's set the feed rates. Here again it is something a little bit different than other softwares, other programs. I will use a feed rate of 3000 millimeters per minute and the spindle speed of 18,500, but this feed rate represents the speed on the two horizontal axes, the X and the Y. After setting the spindle speed of 18,500 RPM, I'm going to set the feed rate on the vertical, on the Z axis, which is a percentage of the feed rate that I have set for the X and the Y. If I want the same feed rate, I'm going to use 100%. And the angle value represents the maximum angle after which any movement is considered vertical, and it will use the speed here. One important thing that you need to remember each time you create an operation in FabEX CNC is to check the output trailer and make sure you have M02 here, which represents a command to make the machine stop everything that is doing after finishing the operation. Otherwise you will end up with a machine that keeps on spinning and you have to manually stop the spindle, move it away, and so on. So remember to put an M02 as output trailer and check it each time you are making an operation. I also can change the milling type from conventional climb or meander, which means it will keep the tool bit down and continue milling in the other direction. It won't take into account a climb or a conventional cut. This will result in a very fast operation, but with final results that might not be as good as using a certain type of operation. So remember, if you want to make something fast, use the meander, otherwise use the climb or the conventional. You can also change the direction of the cutter spin. If you have a right hand spindle, you are going to select the clockwise, otherwise select the counterclockwise. The Z clearance here is the same value that we have already set up above, so I'm not going to change that, and I will leave everything just as is for the rest of the settings. And now let's go to the right and click on the calculate path button. And I have the toolpath for the 3 pockets, but there is a little problem that I don't like, and unfortunately it doesn't have a simple solution in Blender. If you take a look from the top, you can see that the tool bit will leave a roundover for each of the corners because it will try to mill this area, and since it's a round tool bit, it won't be able to mill the corner. In FreeCAD there is a great option for this, which is the extensions. I don't have that in Blender, but I have a solution for this. It's not the best solution, but it's something that you can use whenever you need it. Let's select the curve and press tab to enter the edit mode. Make sure the mouse is in the viewport over the object, otherwise it won't enter into edit mode. And now let's rotate the view. Let's select all the points from the bottom and make sure to move them using the green arrow on the y-axis, and I will set a distance of -3, which is half of the tool bit. Now let's do the same for the upper points. Select all of them, move them again along the y-axis with 3 millimeters. And now I can press tab again to exit edit mode and enter object mode. You can also change it from the top left corner here, but make sure you have the correct object selected before making the change. Now you can see that the areas that I want to mill are bigger with half of the tool bit. Let's calculate the path again. And if I set a top view, you can see now that I won't have any roundovers left for these corners. Of course, this is easy for this shape, which is aligned on the XY plane. Sometimes it might be a little bit more difficult, but this is the only solution for now. The Blender add-on, the FabEX CNC add-on, doesn't have an option to extend the open edges for the pockets. We will encounter the same problem for this area here. As you can see, it has this open edge. Let's first create the operation for this. Let's select the proper curve, which is this one. You can see it highlighted in white. So with the curve selected, click on the plus button to create a new operation. Scroll back up and let's set everything again. Change the strategy to pocket, start position. Leave it inside or outside, it doesn't really matter. Let's set a toolpath distance of 3 millimeters, a safe height of 120 millimeters, and a start depth of 100. The max depth, leave it as object because it will have the height of this curve, which is exactly correctly placed at the top of this pocket. I will change the layers to 3 millimeters, and this is very important. You can see here the end cylinder 6 millimeters is selected, but if I take a look down here, it has some completely different values. This is a bug. Make sure you check the values and select the 6 millimeters again. You can see it has changed the diameter from 3 to 6 millimeters. Let's also change the feed rates. Even though I have set up in the machine, you can see here on the right, if I scroll down, I have some default feed rate and spindle speed, but it doesn't take them into account. It uses some default values. So this is also something you have to remember each time. Let's change the feed rate. Let's also change the spindle speed and the plunge speed to 100%. Let's remember to check the output trailer. The movement will be left as climb, and after generating the operation using climb, we'll take a look at the total operation time and then change it to meander to see how much time we save using that option. Now let's calculate the path. As you can see here, it will take 51 seconds. Now let's go to change the milling type from climb to meander. Click on the calculate path again. And I have the exact same time because the only thing that has changed is the milling of the outside. So it's not a huge difference. This option is very useful when you are creating 3D surface operations. Then it will save a lot of time. So let's change it back to climb. But I have a problem here because the tool bit cannot enter this area here. And I will have a problem with the extensions because I don't have that in FabEX CNC. If I try to edit the curve, you can see that there are a lot of points here. It's going to be pretty difficult to move them correctly in order to be able to make the toolpath enter this area. Of course, I can select a few of the points and move them like this, maybe even some of these points. If I click on the calculate path again, it will now enter this area, but not until the end. There are a lot of problems using this method. I don't like it, so I will undo these changes. And for this special case, I have a solution. It's not going to work all the time, but I think it's useful to remember this solution because you can play around with the curves and find something that will eventually work in your situation. So what can I do in order to solve this? I have this curve and I also have the final curve, which is the bottom circle. So I will press Shift D with the mouse over the 3D view, press Shift D to duplicate it, click it to leave it just where it was. And now I have a duplicate here and the shape that I want to extend. Let's bring the duplicate to the height of this object. So let's go to item and check the Z is 85 millimeters. For the bottom circle, it is 50 millimeters. So let's change the Z to 85 millimeters. Now it is at the exact same height. So now I want to select this initial object and the copied circle. Hold Ctrl to select them both. And from the curve tools menu, select the curve boolean. with a type union. Sometimes it works as it should, sometimes it doesn't. As you can see here, let's enter edit mode. You can see that I still have a line here which will complicate things. That is because of the approximations, the lines aren't perfectly one on top of each other. So let's solve this in case it appears. You need to remember, first try it this way. If it doesn't work, let's delete the boolean. And now with the circle selected, go back to curve tools and select silhouette offset, use a value of 0.01 millimeters. The other options should be the default ones. Click on the OK button. And now I have another copy of this circle which is offset with 0.01 millimeters. Of course, it won't be the exact measurement that I want, but if I'm doing woodworking, it's more than enough. So now select the offset circle and the initial object here. Go back to curve boolean, leave the type as union and click on the OK button. I have now this element here which is barely visible. Let's try to hide some of the objects to make sure we can see what has been created. And as you can see, the boolean now is an outline of the shape that I want to mill in order to get that correct overcut here in the corner. So let's go back to the operation, select it in the tree here and change from the data source, leave it as object, and the object now should be boolean. Click on the calculate path again and you can see that I have all this milling also for the circle, which in this situation, as I've told you, it's not something that works anytime, but in certain situations it is a good solution because I can then continue to mill the circle to the bottom starting from this height. So let's go and do it. Let's now select the bottom circle. You can see here it is at the bottom of this pocket. Click on the plus button again to create a new operation. Let's go to the CNC menu and change the strategy from profile to pocket. Use a toolpath distance of 3 millimeters. Change the safe height to 120 millimeters and I will use a start depth of 85 millimeters. I remember from the positioning of this object that its height was 85 millimeters, so all the circle from the top of the object to that height has been already milled, so I will use a start depth of 85 millimeters. Change the layer height to 3. Change again the tool bit, select the proper one with the proper dimensions, change the feed rate, 305,000 millimeters per minute, the spindle speed and the plunge speed, check the output trailer, scroll down and the rest is exactly as it should be. Click on the calculate path. As you can see, I have the correct toolpath for the part that is only remaining from this circle. But I have 3 different operations which are independent. I can export them, of course, but I have to load 3 files. How am I going to join all these 3 operations into just one file that I can load into my machine and do all the milling in just one go? Here I will introduce the operation chains, which is something very useful, very powerful if you know how to manage it. So let's go here, create a new chain, and I will drag this a little bit up because I want to be able to see everything that I want. I will select the operations one by one from here and then click on the plus button in the second panel of the chains. So after doing this for all the 3 operations, I have one chain that is going to make all these 3 operations in exactly this order. If I want to change the order of the operations, I will use these buttons. As you can see, I can change their order. And now I can select this button, calculate chain path and export G-code, which will only calculate the toolpath. I'm not going to see them on the screen, but I can click on this button, export chain G-code, which will export in the same folder as the file that I'm using, will export the chain G-code, but also each of the 3 operations individual. I'm not sure why it does it, but that's not really such a deal breaker thing. Now let's take a look at the file that has been generated. As you can see, I have the first operation here. It will end and start the next operation and so on. But I can notice here something that I don't like, which is the M02 command after each of the operations. So if I want to optimize things further, I can change these 2 operations and uncheck the output trailer. And now let's calculate the chain G-code again and export it. Let's reload the file and scroll down. Here you can see that I don't have the M02 command after the first operation. Also after the second, I think it's not going to be there. Let's scroll down a little bit. But at the end of the operation chains, I have the M02 because the last operation has that option enabled. One thing that you need to take care is not select them from the chains menu, because selecting the operations from here won't change what is displayed in this panel. So unchecking the output trailer will change it for the operation that is selected in the operations panel, not in the operations from the chains panel. If I uncheck this, you can see that I'm modifying actually the last operation. So make sure you select the operations when modifying something from the operations panel, not from the chains panel. Now I will delete these operations. I've shown you how to group them together, how to make the extensions. One more thing that I want to show you is how to get a smooth surface for the walls of the operations. So I will leave just the second operation, which is this shape. I will delete the other operations. Unfortunately, you can see that I don't have the G-code, the G-code objects deleted, so I have to manually select them and delete them so you can see clearer. I will also delete the curves that define this part so we can see easier. So now all I have is the toolpath for this operation, the main object and the boolean that we have created. Let's say I want to make this toolpath with several layers, and at the end I want to make a final 0.2 millimeters pass on the outside to have nice looking walls, to avoid steps from all these step down passes. How do I do that? Well, let's go to the pocket operation here in the CNC menu and leave a skin of 0.2 millimeters. Now click on the calculate path and export G-code. Let's take a look at what has been modified. I will change it back to 0 so you can easier see. Let's zoom in. So let's use a skin of 0.2 millimeters. You can see the toolpath going inwards a little bit, which is exactly what I want. And after making the rough cut, removing most of the material using this skin, I will select this button, which will copy the active cam operation. But from the start I have an error because the safe height is going to the default 10 millimeters, is not going to be copied from the previous operation. So let's change that to 120 millimeters, uncheck the layers, and I will have only one pass. Make sure the correct tool bit is selected. Make sure everything is just as it was. Again, check the output trailer, and everything else is exactly as it should be. Click on the calculate path for the second operation, and let's set a top view. And I forgot to change the skin, so the main point of what I was doing was useless. Change the skin back to 0, click on the calculate path, and now with the top view you can see that I have one final pass that is going to leave the walls almost perfect, of course depending on the machine that I have. What I've noticed about this option in Blender compared to FreeCAD is that the skin is on the walls of the object, not on the bottom. If you remember from FreeCAD Pockets, if you use a similar option to have a finishing pass, it will make that finishing pass for the bottom of the object, but not for the walls. I think this approach is much more useful, to have the walls a little bit bigger using the skin option, and then make a final pass to make everything smooth. I think it's quicker. And if I want to change the bottom of the pocket, if I also want to make a final pass, I can anytime change the depth of the first operation. So let's select the first operation, go to the operation depth, and instead of max depth from object, I will select custom and use a value of 85.2 millimeters. This means that I will also have a skin on the bottom of the pocket. Let's calculate the path again. So now if I take a look at the first operation, it will, let me just zoom in a little bit more, it will make the final pass here, and the second operation will be just a little bit lower with a final pass of 0.2 millimeters, both on the walls of the pocket and on the bottom. After creating the two operations, I can go back here, create a new chain. Let's rename the chain pocket with skin. And now let's select the two operations, click on the plus button to add them here, click on the plus button again to add the second one. Let's also select the first one from the operations panel, scroll down, uncheck the output trailer for the first one, and make sure for the last one I have the output trailer. Now I can calculate the chain path and export the G-code. Click on the export chain G-code, and I have the file ready to move on to the CNC and mill everything with a final pass for this pocket to have perfectly smooth surfaces. So this is the way you create pockets in Blender using the FabEX CNC add-on, the formerly known as Blender Cam add-on. It's a very powerful solution compared to FreeCAD, especially when importing various other files in the STL format. You don't have to recreate two objects or use just the 3D surface operation. Using this add-on, you can generate the curves that define the shapes of the pockets. I will show you just a quick different example. Let me just delete everything here. I will import another file, which is an STL downloaded from Thingiverse. So let's say I want to import this very nice wooden rail junction, and I want to mill it using a normal pocket operation. In FreeCAD it's impossible. I have to either recreate the object or use the 3D surface operation. In Blender I can easily do it. Let me just align the objects, the object transform align objects. First select the Z, then click away, select the object again, transform align objects on the x-axis, do the same again on the y-axis. It doesn't work to click on the three of these axes one after the other. One final thing, select the object, right click on the 3D cursor, origin to 3D cursor, and now I have everything aligned as it should be. And now if I select the object, click on the get pocket surfaces, it will take a little bit longer because I have some roundovers here, but I will show you exactly how easy it is to get these pockets. It's not the perfect solution, it doesn't always work perfect, but you can easily remove everything that is extra and keep just what you want. As you can see, I have a lot of objects here. I can reduce their number by changing the horizontal threshold. I will use a horizontal threshold of 0.999. And now I only have 105 objects. It's still a large number, but I can zoom in a little. Let me just move this to the side. I can move it and select the correct pocket. You can see that I have this exact shape, and now I can mill this just as a simple pocket, not using a 3D surface operation, which would take a lot of time and would also result in a bad final result. Using the FabEX CNC, I have this great option, which is able to generate the shape of the pockets from a simple 3D object, from an imported 3D object. This allows me to make a lot of objects that I can download and simply mill them on the CNC very fast using simple operations. I will show you in another video how to make this particular object, this rail from wood, how to make all the toolpaths to get the correct shape, how to use V-bits to generate the walls, the tapered walls, how to make the roundover with simple operations, how to make an outline of this object, how to use tabs to hold it down to the table. So don't forget to subscribe to the channel if you haven't already subscribed. Keep close and I will show you a lot of other videos in the near future. Thank you for watching and see you next time.